Hi, in this video, we're going to take a look at the OSPF metric called cost. So the OSPF metric, known as cost, RFC 2328, the most recent RFC for OSPF v2, doesn't specify what that means, what should be used. It's really just up to the vendor. Well, Cisco IOS uses 10 to the 8th, 100 million divided by bandwidth in bits per second. And then what we'll see in a moment, it's the cumulative bandwidth of all the outgoing interfaces from this router to the destination network that determines the overall metric, the overall cost for reaching that network. And that's what we see in the routing table. Okay, 10 to the 8th, or 100 million nodes, is the reference bandwidth. And we're going to use that number divided by the bandwidth. Now, the reason we do that is we want our bandwidth values, the larger numbers, to be divided by something to give them something smaller. So basically, we want to take the inverse. We want to take our higher bandwidth numbers, make them look lower, and our lower bandwidth numbers and give them a value that's higher. Because like RIP, 3 hops away is better than 10 hops away. Lower the number, the better. All right, so if we look at this table here, and we take our 100 million divided by the bandwidth in bits per second, okay, we get some cost values. Okay, now these may look kind of strange, the first 3, because they all have a cost of 1. That's because our reference bandwidth is 100 million. 100 million divided by a value, well, we can't have less than 1. So gigabit and 10 gigabit get a cost of 1. But we're going to talk about that in a moment. But look at our Ethernet serial and then our serial links. The slower the links, the higher the cost. That's what we want. But you know what? We don't like that our gigabit, fast gigabit, or 10 gigabit all have the same value as our fast Ethernet. Okay, so what we need to do is actually just change our reference bandwidth value. Okay, so we can do that using the auto cost under the router OSPF command. Auto cost reference bandwidth in megabits per second. Okay, and we want to do this on all of our routers in our routing domain. All right, so let's take a look at how this works. So if I said auto cost reference bandwidth 10,000 megabits per second, okay, what that gives me is a reference bandwidth of 10 billion. So I'm taking 10 billion and dividing it by my bandwidth in bits per second. And now you can see my 10 gig, and fast Ethernet costs all vary, with fast Ethernet being higher than gig, which is higher than 10 gig. And that's exactly what we want. Okay, so if I use the auto cost reference bandwidth 1,000 megabits per second, okay, instead of 10,000, let's see what we do. I'm going to do that on all 3 routers here. That's because I don't have any 10 gig interfaces. I just have a 1 gig interface. Okay, so our cost for our gig interfaces will be 1. Okay, serial interface for our default T1, 1.544 megabits, that gets a cost of 647. All right, let's take a look. If I do, here we go. All right, show IP OSPF interface. So on R1, if I do show IP OSPF interface serial 000, I actually see the cost for that specific interface. Okay, which again is our reference bandwidth divided by the actual bandwidth in megabits per second. Okay, this shows a cost of 647. Okay, so how do we see it in the routing table? How does this all work? We always said it's the cumulative costs of the outgoing bandwidth. So let's take a look. I do show on R1, I do show IP route, and I'm just going to take a look at the 172.16.2.0. Okay, I get a metric of 648. By the way, that number preceding it, the 110, is the administrative distance for OSPF. Okay, and if I do show IP route and specifically that network, I get actually more information. It tells me specifically the metric is 648. So how did it come up with 648? Well, let's take a look. The outgoing interface of gig 00 on R2 was a cost of 1. The outgoing interface on R10000 is 647. Okay, we add those together and we get 648. That's what shows up in the routing table. A lot easier than EIGRP, isn't it? All right, that's the OSPF metric, the cost.